Agriculture is facing major challenges to respond to the growing demand for food, calories and fuels in a world where population is expected to increase to 9 billion in the decades to come. Across the 20th century, industrial agriculture has represented a paradigm shift from the traditional farming system, proving great increase in productivity and efficiency, making food abundant and affordable. This was the result of the application of knowledge, including engineering, chemistry and genetics, new technologies and managerial practices to crop production. At the same time, agriculture has largely ignored the externalities generated by the novel industrial farming practices at environmental and social levels. At the moment, agriculture systems that rely on monoculture, large use of chemicals and heavy mechanization are also contributing to the degradation of key ecological and social interconnected processes. These methodologies drive climate change, loss of biodiversities, erosion and contamination of soil, fresh and marine water eutrophication from phosphorus and nitrogen fertilizers. Consequently, an increasing demand for the development of sustainable agriculture techniques has raised, and farming activities are now required to respond to the food challenge while protecting the natural environment, being socially and fair and equitable, and economically viable and beneficial. The question, therefore, are: what does sustainability mean in agriculture, or what is sustainable agriculture? Sustainable agriculture, in our view, embraces several techniques and practices such as low inputs, holistic, regenerative, ecological, alternative, organic and biodynamic. Just because a farm is using organic or regenerative methods, it does not mean that it is sustainable. More precisely, to be sustainable, agricultural system and crop production processes are required to respect some key principles. First of all, they need to be designed to respect, protect and conserve ecosystem processes and biodiversity, such as nutrient cycling, nitrogen fixation, soil regeneration, water cycling, predation and parasitism. Second, they need to increase the efficiency in the use of resources and minimize the utilization of non-renewable inputs such as pesticides, chemical fertilizers and other pollutants that can generate harm to the ecosystem and the consumer and the farmers. Third, sustainable agriculture means enhancing the resilience of communities, respecting the equity and the social well-being of farmers, while integrating their knowledge and skills about crop practices. Finally, the last principle refers to the development of governance mechanisms that favor collaborative behavior among farmers and landholders, agro-food and financial companies, NGOs and local institutions, in order to address in a sustainable way environmental and natural resource concerns and challenges. To sum up, sustainable farming does not mean a return to the past or to the techniques used before the so-called Green Revolution. Instead, it means combining traditional techniques that focuses on ecosystem and soil preservation with modern and innovative technologies and practices. We are now going to briefly illustrate some farm management options that can contribute to increase the resilience of social ecological systems. First of all, we can mention crop rotation, which represent a central component of every sustainable farming system. Crop rotation is the practice of growing a planned succession of various types of crops in the same field. This is a traditional technique and can increase yield significantly, up to 15–20%, when managed in a proper way. For example, including at least one soil-conserving crop, such as perennial hay, or nitrate trapping and nutrient-enriching crops, such as various legumes. Besides improving the chemical and physical properties of the soil, this technique reduces the risk of soil erosion, helps preventing water runoff, provides better weed and insect control, and can generate social and economic benefits. A second example of a sustainable farming strategy refers to limiting the use of pesticides for what is commonly called integrated pest management. This is a general term that includes a range of different methods like mechanical and biological control techniques that encourage the proliferation of beneficial microbes and insects, predators and parasites, and allow to keep pest population under injurious levels. Other techniques are related to use of specific practices, such as tillage methods and plant residue management, in order to optimize the characteristics of the fields and make them inhospitable for pests. Integrated pest management are among the best options available to reduce the use of pesticides. Another example is organic farming. Organic agriculture slowly developed starting from the 70s, but in more recent times, a global market for organic product has sharply developed in many countries, thanks to the growing demand for sustainable food and to the diffusion of legally enforced cultivation and production standards and certification systems. Rules for organic farming practices differ from country to country, but there are some common principles. Avoid or limit the use of synthetic chemical inputs such as fertilizers and pesticides, of antibiotics and of other additives. Not use genetically modified organisms. Protect ecosystem and biodiversity. Use local resources. Follow strict physical separation of organic products from non-organic ones. Organic farming is still facing relevant obstacles linked to higher costs, risks, and limited knowledge from the standpoint of the farmers, but it is a very promising option when it comes to sustainable agriculture. Another sustainable solution is the integration of livestock and crops. The industrialization of agriculture has contributed to strong specialization that leads to separation of plant and animal production, with crops cultivation located far away from livestock and manure fertilizers. On the other hand, organic fertilizers such as animal and green manure are important sources of organic material that improves the soil structure and favor water retention capacity. A growing body of evidence demonstrates that a farm that grows different variety of crops and raises livestock can increase its efficiency and improve the overall sustainability. The last example refers to precision agriculture, which is a relatively novel farming approach that can significantly enhance efficiency and land productivity. Moreover, it is key to increase the sustainability of agriculture. Precision agriculture can be defined as a management system that uses information technologies, computers, satellite positioning systems, and remote sensing devices to provide site-specific information, such as data on soils, crops, nutrients, pests, moistures, or yields, with the aim to improve the quality of farmer decision-making. Thanks to data that are made available to farmers, in fact, agronomic practices can be tailor-made to the specific local condition within a field, improving the accuracy of the agronomic practices and optimizing the profitability and environmental protection. To conclude, agriculture is a fundamental component of our social ecological system, and the development of sustainable agricultural practices is vital to preserve healthy ecosystems and the natural services on which rests human well-being. This calls for a profound transformation of agriculture and for the rapid diffusion of sustainable agronomic techniques.